Hello, and welcome to this Tungsten Cluster Masterclass training session, where we take a look at the Cluster-Extractor, enabling you to replicate out of a Tungsten cluster. My name is Chris Parker, VP of Customer Success here at Continuum. In this course, we'll explore what the Cluster-Extractor is and how it works. We'll discuss the possible use cases and targets available. We'll also then review the configuration, and I will close with a demonstration. So what is a Cluster-Extractor? The Cluster-Extractor is a single installation of the standalone Tungsten Replicator product, configured in a specific way that allows you to replicate from an existing Tungsten cluster into a standalone target. This works by reusing THL that has already been generated within the cluster and repurposes it to replicate into a node that is not part of that cluster. This node can even be one of the supported heterogeneous targets. Additionally, filtering can be applied. So for example, you could choose to just replicate one schema or even one table to a dedicated non-cluster node. This can serve a useful number of needs. The replicator remains fully cluster aware, so if the primary node within the cluster fails, replication will still continue, as the replicator will still be able to source THL from any node within the cluster. If you're using MySQL as your standalone target, you could even configure bi-directional replication so that the single node can replicate back into the cluster. Here's just a very simple diagram explaining what it looks like. On the left, you have your primary node and your two replica nodes, and then we have the Tungsten Replicator installation, which is sourcing the THL. It will only take the THL from one of the three nodes, but that will automatically reconfigure should the node that it's currently pulling from go offline. The replicator can then write into that target, whether that's another MySQL target or a different flavor of database. The Tungsten replicator itself ideally would be installed on the same host as the MySQL node, but it could be installed on a different dedicated host if required. So why use the Cluster-Extractor? Well, you could offload backups to an external node, so you could use the Cluster-Extractor to replicate your entire database without any filtering into another MySQL node, which you then use for backups. It could be used to provide dedicated reporting for different business functions where you want to offload potentially heavy SQL queries that may slow down your application. You can move them into a dedicated node. And if it's reporting, you may not want to use MySQL. You may find other database types more suitable, such as Redshift or Vertica, for that better data warehouse reporting. And as we say there, we can feed that into that non-related external system. So it's especially powerful for heterogeneous targets. So what are those heterogeneous targets? Well, as you know, Tungsten Cluster is a MySQL solution, so the cluster itself would be MySQL, but then we can replicate out from that cluster into any of the targets you see on here. So obviously into MySQL and all the various flavors of Cloud MySQL, so that's an Amazon RDS, Amazon Aurora, Cloud SQL, Azure. But then the heterogeneous targets we can also replicate into the likes of Oracle, Redshift, Kafka, Postgres, Vertica, Mongo, and Hadoop. So let's have a quick review of what that configuration looks like. So it would be very similar to a normal standalone cluster in that you have the default specified. Here we have the default specified just to enable the API, the location of the installation. I'm disabling security controls for my demo just for simplicity, but obviously they are enabled by default. You then define the cluster definition. So here you see alpha. The topology in this case is what we call a cluster-alias, and you define the master node and the members. You don't need to specify the connectors here, but the one key thing to point out is the service name alpha. That must match the same service name that is being used in your source cluster. You then define the properties for the Cluster-Extractor. I'm calling mine here in this example reporting. The relay is the host that we're installing the replicator on. The relay source, so where do we source our THL from? So that then points to alpha, which is the cluster alias above. We have the topology, which is a cluster slave, the replication user password and ports for writing into the target database. And then we have, in my case here, I'm enabling some filters. So I'm enabling the replicate filter, and I'm saying only replicate the HR schema. So this would be an example of, for example, if my source cluster had multiple different schemas, but for my offboard extractor, I only want to replicate HR, therefore I'll just replicate HR. If you are applying to a heterogeneous target, something like Oracle or Postgres or Vertica, there may be additional properties required in the cluster. Additionally, you may also have a slightly different configuration here for the Cluster-Extractor. There's a lot more examples of that in our online documentation. And we also discussed the heterogeneous targets in a little more detail in our Replicator masterclass training sessions. Feel free to obviously explore those if you wish. The key thing to note is when you're provisioning, you can either use the T-provision tool if you are doing an entire full replication flow, but if you are only doing a subset of data, you may need to export that data from your cluster. I will show you this in the demo, but to do that, you would need to make sure that you select one of the cluster nodes, shun the node so that clients are not reading stale data, take the replicator offline in that replica node in your cluster, extract the data you need and import it into your targets. Then you're kind of given a starting position for that replication. So let's move on to a demonstration and I'll show you how this looks in practice. Okay, so on here I have 3 terminal sessions, DB1, DB2 and DB4. So DB1 and DB2 are cluster nodes. DB4 is going to be my cluster extractor, my destination for my replication. Now my cluster does have DB3 running, but I'm just not showing that. I don't need to show that for the purpose of this demo. So I'm just going to show you the cluster itself. So we have alpha is my cluster. It's made up of DB1, which is the primary node. DB2 and DB3 are replica nodes. So the first thing I want to do is I want to load the data into my target MySQL. I want to seed the destination. First of all, I'm going to shun DB2. So when you shun a node, it just takes it out of the pool of targets that the connectors will use. So any clients coming into the connector won't send connections to DB2. It will isolate that cluster node. And you want to do that because what we're about to do now is we're going to take the replicator offline. So when you shun a node, the replicator is still applying changes. It's still keeping up to date with the primary node. We don't want that. We need to be able to take an extract of data that is at a known position. So now we can take the replicator offline. Oops, DB4 doesn't exist. No, it doesn't. Let me just replace that. Okay, so now the replicator is in an offline state. The node is shunned. So that node is now isolated. Okay, so what I can now do is take an extract of the data. But what I need to do is I need to put my details in here. Databases. I want to extract the schema or tables or whatever it is that you want to set up as part of your filtering. So in my case, the HR schema. But I also need to take the tracking schema, which in my case is tungsten _ alpha. Tracking schema is always tungsten _ and then whatever your service name is. So our service name is alpha, the tracking schema is tungsten alpha. And let's just output that to a file. There we go. So we have that file here. Now why do I want the tracking schema? If I just go into the database and I use tungsten alpha, show tables. We have a table in here called trep commit seek now. And in this table, it gives us the position of the replicator. So because we've stopped the replicator and we know we're not receiving any more changes, we know that that database is now at a static position. So if we take an extract of this trep commit seek now table, this sequence number and this bin log position is the last change that was applied to this database. So it's kind of like gives us the position for the replication to start from so that we know that we're up to date. So what I'm going to do now is just come out of here and I'm just going to go into the primary node. I'm going to use HR. If I just do a select star from regions, I've got 4 records in there at the moment. So let's just insert a new record. This will all make sense when we start the replication. Oops, values. I've got an auto increment on there. Training region. Okay, so we now have a record in there in the cluster, but that record isn't in our extract because obviously we've taken an extract before that change has been made. So I now want to, obviously we can show that when we import the data and we start replication, that record will appear. So if I come out of here, I can go into ccTLR. I've taken my export of the database. So now we can actually bring DB2 back into the cluster. So we can do data source, DB2 welcome. That will put the replicator back online. There we go, the replicator's back online, the node is back in the cluster, and it can now be used as part of the cluster. We don't need to worry about these nodes anymore. So I can come out of here, and I can even close this session down. Okay, so now we have the primary node here, and this is our data source node that we are going to start importing the data to. So the first thing I need to do is import that dump file from DB2. Obviously, I forgot to send it across from DB2, so I'm just going to do this, bring that file across. So I've got my database file there now. So MySQL user tungsten. Okay, we can say use HR. We say that's not there yet, the database doesn't exist. So let's do MySQL tungsten secret import backup.dmp. So let's bring that data in. Let's log in now. Use HR. That database is there. Show tables. Select star from regions, and we'll see in here we don't have that new row that I added, that training region, and that's good. Let's use tungsten underscore alpha. Select star from trep commit seek now, and we can see that's the record as it was on the cluster when we extracted it, the sequence number position 213. So the database is now seeded, we have our data in there, and now we can install the replicator. So opt continuance software tungsten replicator 801. Okay, I'm just going to show you the INI file that I have ready. So it's exactly as I showed you on the slide deck. So I have all the information there. Tools tpm install. This will just take a moment to install this. What will happen is now when I start the replicator up, because we've preloaded that tungsten alpha tracking schema and we've got that record in there, when we start the replicator up, it will go to that tracking schema as if to say, right, okay, I want to come online, where do I need to come online from? It will see that sequence number 213 has been applied already. So it will then make its connection to the source cluster and effectively say, give me everything from 213 onwards. So that it will get any other changes that have been made to that cluster in the meantime. So I'll just come out of here, preload my environment, and I can do replicator start. Okay, replicator is running, and I can now look at trepctl status. You can see we're online, and we can see the sequence number is already incremented to 214, which implies that it's probably pulled over that record that we made that change to in the source cluster. But before I show you that, I'll just run through the output of trepctl status. All the information here is exactly the same as what you've seen on previous training sessions. It has the status, the bin log position of the last item we applied, latency. Obviously there's not a lot happening on my cluster at the moment, so the latency is going to be a bit off. But when data starts flowing and when you're in a proper production environment, those latency figures will look more realistic. The cluster name, so this is the reporting service name that I gave it, but then there's the simple service name down here and the service name as alpha, because that's the service name of the cluster that we're connecting to. The only difference from a normal replicator trepctl output here is when you see this master connect here. So what it's saying in master connect URI is it has a list of all of the cluster nodes that it could potentially get THL from. So it can pull THL from DB1, from DB2 or DB3. THL is the same on every node, so we can just go through any of those. By default, it will know that DB1 is a primary node. So by default, we won't pull THL from a primary node because we don't want to add any additional overhead to that host. So what you'll see in pipeline source is we're actually sourcing our THL from DB2, so we're taking it from a replica node. In the cluster, if we were to do a switch and promote DB2 to be the primary, this pipeline source would change. So I'm going to do that now. Switch to DB2, so I'm making DB2 the new primary node. We'll just let that run for a second. Whilst that's running, I'm just going to log into my database over here, connect to HR, select star from regions, and we can see we have that new training region has appeared. The switch over here has happened. So let's go and have a look at trepctl status now. And we can see the pipeline source has now switched to DB1 because DB1 is now a replica node. DB2 is the primary, so it has automatically reconfigured itself to pull from a replica. So this happens automatically all the time. In traditional native MySQL replication, if a node was to go down or you needed to change the source node, there'd be a lot of manual commands to run to do that. But with Tungsten Replicator connected to a Tungsten cluster, all of that is all automatic. And that's it. That's all there is to it. Very simple and very straightforward. So what have we learned? Well, we went through what a cluster extractor actually is, looked at the possible targets, so the heterogeneous targets, and then we looked at the configuration files, and I showed you a demonstration of how it works and how it's set up. I hope you found it useful, and I look forward to seeing you on a future training course very, very soon. Thank you and goodbye.